All right, this is the second video on prime numbers. And so we're going to start out with this concept called the least common denominator or the least common multiple. And so this is a three-step process. So the first step is factor each denominator. Step 2 is, what is step 2? It's been a while since I taught this. I used to tutor this all the time, but now I'm trying to make a video for it. So then after we factor it, then we underline. Underline the highest contribution of each factor. And then step 3 is the LCD is equal to the product of everything underlined. Okay, so suppose we have 3 eighths and we're adding it to, let's have a denominator of 12, so 7 twelfths. And so we want to find the LCD here. So 8 factors as 2, 2, 2, and 12 factors as 2, 2, 3. And so I have these two factorizations. And so that's step 1. Step 2 is underline the highest contribution for each factor. So one of the factors is 2 and the other one is 3. So for the 2's, this is the greatest thing. I said underline it, but I circled it. And then a 3, I guess I'll underline the 3. So then the 3 is the highest contribution. So then the LCD is the product of everything underlined. So the LCD is equal to 2 times 2 times 2 times 3. So 2 times 2 is 4, times another 2 is 8, times another 3 is 24. So the LCD is 24. And so we'd want to convert each of these fractions into 24. So the 8 is here and the 12 is here. And so the bottom underlined things is what the 8 is. And so what's missing is the 3. So if I multiply top and bottom by what's missing, then that would give me the correct thing. And the 12 is here. So what's missing is a 2. So if I multiply top and bottom of this one by what's missing from its factorization to the LCD, so I get 9 plus 14 over the common denominator of 24. 9 and 14 is 23. So that's 23 24ths. You can barely see it there at the bottom of the screen. So this LCD plays a role in a lot of different things, but adding and subtracting fractions is one of its prime deals. All right, the next thing is the greatest, the greatest common factor. So the greatest common factor. And in order to do that, it's also a multi-step process. Step 1 is factor each number. Could be a numerator and a denominator, but it could also be a, like just if you're trying to find the greatest common factor of two numbers and they're not involved with fractions at all. Sometimes you need to do that. Step 2, I guess I'll make this a little bit more detailed. Make a list of the unique factors. Step 3, find what is common in each of the trees for the factors. I guess you could say the smallest contribution of each factor. No, that's not really true either. It has to be, they have to be common. All right. So let's give a couple of examples. So suppose we have, well, let's do 8 and 12 again. 8 factors as 2, 2, and 2. 12 we saw factors as 2, 2, and 3. So what's common here is 2 of the 2's are common. So the list of the unique factors would be, again, 2 and 3. So then we look at 2. What's common with the 2's? A pair of them. What's common with the 3's? Nothing, because there's one over here and none over here. And so so then the greatest common factor is the product of everything underlined. So 2 times 2 is equal to 4. So the greatest common factor here is 4. So that's how you find the greatest common factor. And we use the greatest common factor when we reduce fractions. So like suppose we had 8/12. Well, we found that it was 4. So we would divide top and bottom by this greatest common factor. 8 divided by 4 is 2, and 12 divided by 4 is 3. So 8/4 is 2/3 when we reduce it. And so the greatest common factor comes in handy for what we call reducing fractions. And if we have a number line, and in thirds, 1/3 is here, 2/3 is here, 8/12 is here. It's the same spot. And if we multiply 2 and 3 by 5, 2 times 5 is 10, 3 times 5 is 15. 10/15 is also right here. It's the same address on the number line. And of course you can't see what I'm writing. Let me do that. So I have 8/12 here, 2/3 here, and 10/15 here, multiplying top and bottom by 5. And if we multiply top and bottom by any number, like a 7 or a 23, you know, whatever we want, all of those reside right here at this point on the number line. So when we talk about reducing a fraction, we don't mean making it smaller. We mean making the numbers in the fraction smaller so as not to change its address. So I wanted to clarify that too. So that's the greatest common factor and the least common multiple. And so sometimes these things can come up. Like suppose you have, let's do a more complicated problem. Suppose you have, let's say 3/4 plus 5/16. Then you wanted to add these. But also let's say we're, let's put a 2 out here. Well, the first thing I can do, I guess, is distribute the 2 across, and that'll cause some reduction. So this will be 2 times 3/4 plus 2 times 5/16. The 2 will go into here twice, and the 2 will go into here 8 times. So then we have 3/2 plus 5/8. And then, well, I wanted to show factoring or whatever, but all right, so let's just finish this out. So let me clean this up. 3/2 plus 5/8. Well, clearly I need to get to 8s because 2 goes into 8 and 8 does not go into 2. 8 is composed of, well, let's do the least common multiple. So if I factor 8, I get 2, 2, and 2. Can you see this? Of course not. And then 2, of course, is just 2. So the LCM has to be that greatest contribution. So it's the 3 2's. So 8 is the LCD. So what's missing from the 2? With just one of them would be 2 of them. So I have to multiply top and bottom by 4. So I get 12 which is 4 times 3, plus 5. 12 plus 5 is 17 over 8. Can you see that? Yes. And then if I reduce this, 8 goes into 17 2 times, so it's a whole number of 2, and that's 16. So there's 1 left over, so 1/8 is. So the greatest common factor and the least common multiple show up as a immediate practical application of the prime numbers. So this was my second video on prime numbers. Thank you for watching.